In 2018, when rushing to install the FIU pedestrian bridge, improper calculations, project crunch to meet urgent deadlines, and gross negligence toward glaring red flags led to a clearly preventable tragedy that claimed innocent lives. It was a busy March afternoon in 2018 at the intersection of Southwest 8th and East Campus Circle in Miami, Florida. Southwest 8th Street being an 8-lane thoroughfare on the north side of FIU, or Florida International University's, main campus. This particular area was slightly congested in recent weeks, owing to construction of FIU and Sweetwater's new pedestrian overpass that would bridge the campus and the suburb of Sweetwater near 3 main parking garages on the FIU side, connecting near the also newly implemented the one at University City off-campus housing under construction just on the north side. The pedestrian bridge would allow campus-bound students to cross 8 lanes of traffic and the nearby canal safely and with relative ease. Also apparent was that this overpass would be a significant source of pride for FIU, Sweetwater, and their partners, evident by its truly unique design, artistic influences, and bold promotional campaigns, and especially since the university is home to the acclaimed Engineering School of Construction and specifically FIU's Accelerated Bridge Construction, or ABC, program. Under construction but not entirely impeding traffic on Southwest 8th, the FIU pedestrian bridge project had reached a point where only 2 lanes needed to be closed for its continued work. On Thursday, March 15, 2018 though, at roughly 1:45 p.m., the bridge suddenly collapsed. Along with the 8 vehicles that impacted, a small crew of workers had been present atop the canopy of the structure as well. This catastrophe injured 10 and claimed the lives of 6, 5 of which in occupied vehicles underneath and 1 of the workers. Ultimately designed to be a concrete truss-supported, asymmetrical cable-stayed or suspension bridge in appearance, the idea itself underwent many ups and downs over the years due to budget issues. The suburban city of Sweetwater, home to much of FIU's off-campus housing and flanked by university locations, the College of Engineering location to the east-northeast, the main campus directly to the south. The 8-lane Southwest 8th Street cuts right between the two and is actually Old Highway 41, the main surface road directly into and out of downtown Miami. The volume of pedestrians needing to cross has been a well-known safety hazard for years,
including 18-year-old Alexis Dale, who moved from San Diego this summer to attend the university. Sadly, one day before the beginning of school, she was fatally struck as she was crossing 8th Street and Southwest 109th Avenue early Sunday morning.
Through a partnership between FIU, the City of Sweetwater, FIG Group, and Mania Construction Management, or MCM, the design, control, and sign-off would ultimately be down to the Florida Department of Transportation, or FDOT. This bridge was to be a 2-span, covered, non-redundant, concrete truss in its load-bearing structure, with a decorative tower above reaching down onto the roof portion, with ornamental steel pipe stays emulating the look of a cable-stayed or suspension bridge. Asymmetrical and complex designs, though, in load-bearing structures like these are challenging and require the utmost professionalism in engineering and calculations. At a cost of roughly $12 million, a total length of 320 feet including the stairs and landings at each end, the main span would weigh in at 950 tons and be 175 feet in length to accommodate the 5 eastbound lanes and 3 westbound lanes, with a walkway proposed for a later separate addition leading directly into the PG4 red parking garage on the FIU side. Previously 11 feet shorter, a design revision in October of 2016, requested by FDOT, brought it to this length, requiring a future eastbound bus lane be accommodated as well. The second span over the canal would be 99 feet in length, and the tower would stand at 109 feet, directly above the berm between the canal and Southwest 8th. Mania Construction Management, or MCM, would be the primary contractor on site for construction work. Now, important to note here is just how unique all of this was, and that's not just opinion. This was overt and intentional in the bridge's design. While concrete box girders have become increasingly common, up until recent years the concrete or composite truss bridge was extremely rare, trusses having almost exclusively been composed of steel in the past. The single, non-redundant, centered line of trusses, along with such a heavy canopy, were also somewhat unique. However, it was the faux cable-stayed tower as decoration that raised the most eyebrows in architecture and engineering communities, as this would be a massive amount of additional static load for the sake of aesthetics alone, practically unheard of in the world of bridge engineering at this magnitude for purely aesthetic purposes. Not impossible, but again, very complex and requiring the utmost professionalism in planning and design. Indeed, Fig Group makes this the pillar of their work, something that has drawn so many customers in. Bridges as art, they call it. The concrete would be composed of the up-and-coming self-washing composite material that we're seeing more and more of lately, along with rebar reinforcement. This self-washing material is meant to keep the bridge looking fresh and new, preventing it from taking on the typical dingy gray color seen in so many older bridges. Since load-bearing was fully dependent on concrete truss members, this new self-washing composite would be the primary structural element, aided only by rebar, and would no doubt be put to the test here. Finally, the main span would be assembled and transported into place under the Accelerated Bridge Construction Program, or ABC, a program that FIU prides itself on, even to this day. This meant via this revolutionary ABC program and its innovations, the process would seek to minimize the disruption of traffic when building new bridges. The ABC process uses planning, design, materials, and methods to reduce on-site construction time. It's safe to say that with the volume and frequency of pedestrians crossing such a busy street, it begs the question, why has this not been more of a priority in general for the local municipalities here? As with most disasters of this type, it's rare a single cause or single party is to blame, and this particular collapse, in fact, served a stark example in chain of failures and the arrogance of groupthink, modern times and current year argument being no exception, and providing no immunity to this fallacy. Initial construction would take place in an assembly yard parallel to Southwest 8th on the FIU side of the road. The two main bridge piers that would hold each end and this main span would receive highest priority to both assemble and get put in place. The goal being as little amount of road closure as possible, and the ABC process is what drives the majority of an operation like this. Assembly nearby on false work, instead of spanning across the road obstructing traffic, then transporting the main span, in this instance, swinging it into place with the use of SPMTs or self-propelled modular transporters. As with many aspects of bridge construction though, this is obviously much easier in concept than in practice. See, the process of moving an assembled structure this heavy as a single unit, even just a few feet, let alone rotating its orientation, changing the lifting points, the leveling of its plane it sits on, etc. It's meticulous, time-consuming, and puts severe strain on it, even under the best of circumstances. The goal, once the concrete sets in a bridge like this, and of this particular portion, is to have all load-bearing members under what's known as compression. Concrete is notoriously weak under tension, but much stronger under compression. The use of rebar helps to mitigate this somewhat, but to oversimplify, think of standing a rectangular stepping stone on its end and stacking something on it, versus placing this stepping stone flat like a bridge across two supports at the very ends and then doing the same thing. With the concrete now under tension, it's much more prone to cracking and giving way. The same applies when pulling the concrete, another form of tension, like pulling on a spring instead of compressing it. This is known as the concrete's tensile strength, and while much lower than its compressive strength, these factors must still be calculated and well understood, even when its primary purpose will be to undergo compression for most of its life. As assembly and casting neared completion in the yard atop the false work, as expected, compression and tension were not in equilibrium. Along with the rebar skeleton inside each concrete member, each truss also contained what's known as post-tensioning rods. These rods allow crews to increase or release tension in each, bringing them into the desired condition for the application. In this instance, every member in compression being the goal. With each truss member and their respective joints or nodes in equilibrium atop the false work now, it was time to lift the structure onto the SPMTs. The kinematics of these new forces meant equilibrium would be lost again. The bridge being lifted onto transports from a different position meant post-tensioning would be reapplied, bringing them back into a state of compression inside design tolerances. Transport would be carried out quickly though. As a matter of fact, while the ABC process has gained popularity in the last decade or so, the FIU bridge was to be an example of this portion being carried out in seemingly record time.
The bridge in Georgia took several months to build, then about 60 hours to move into position. The one in Florida took just 6 hours.
While it's gained popularity and slowly become commonplace, especially to replace older interstate bridges reaching the end of their lifespan, Accelerated bridge construction is incredibly nuanced, and forces must be factored in that quite possibly would have never been considered in the past when building a bridge affixed in place. With the SPMTs in position, it was time to lower the main span onto the bridge piers. However, the piers would also be fitted with shim stacks, spacers essentially, to temporarily hold it up slightly higher than setting it straight down onto the piers themselves. With this structure now out of equilibrium again, post-tensioning would take place to bring all members back into compression. Cracks had appeared though, causing a loud distinct sound heard by workers in node 11-12, the joint where truss members 11 and 12 intersect, during assembly atop the falsework, 19 days prior to this on February 24th. These cracks continued to spread, visibly worsening, documented closely by several managing parties involved, until, during more tensioning operations atop the canopy, the concrete at node 11-12 blew out entirely, the first failure point, followed near simultaneously by failure points 2 and 3 and the subsequent instant collapse onto the road below. These events began well before the assembly yard though, and to understand it, we'll need to dig deep and go back 16 months, back to the drawing board, so to speak.
We've already communicated to the developer that to speed up the bridge.
It's called Accelerated Bridge Construction, or ABC for short.
Accelerated Bridge Construction.
Accelerated Bridge Construction. Some dub it an instant bridge.
Speed up the bridge and worry about the streets and the plaza afterwards.
Now, keep in mind this sequence of cause and effect was only put together after a painstaking 19-month-long official investigation by the NTSB and their partners, which even then was drawn out beyond this due to complications with major parties involved in the bridge attempting to effectively absolve themselves of any wrongdoing at every turn. This digest here, for example, by the NTSB, was published as recently as February 2021, a follow-up report to the official HAR 1902 report from October of 2019. When designs of this nature are drawn up, it's common practice for them to undergo an independent peer review. Essentially, third-party consultants in the field certified to evaluate calculations, load-bearing capabilities, and other related engineering checks to ensure drawings and plans meet specifications and requirements for planned use. FIG Bridge Group, the engineering firm of record, would bring on Lewis Berger and Associates for this quality control process. However, investigators found out the Lewis Berger firm was not qualified by the Florida Department of Transportation for this type of complex bridge certification, and being the final say-so in a project like this, FDOT should have independently verified this information before signing off. A similar process also takes place once construction commences, and third-party engineering consultants will be present on the job site to administer, monitor, and inspect as construction proceeds. Mania Construction Management, the firm hired by FIU for the construction work on site, would bring on third-party Bolton, Perez, and Associates consulting engineers for this task. FIG Bridge Group's designs were non-redundant, providing only a single load path, meaning essentially if one member fails, total collapse is likely to follow. Not entirely uncommon in the world of structural engineering. However, FIG was creating this design based entirely and almost unbelievably on the fact that they erroneously considered this structure to actually be redundant, and had created their calculations and needs for load-bearing capacity on this false factor of redundancy. A bridge this unique with one single row of trusses, not even trusses on either side like most bridges, what path was the load to take if a member broke? The level of incompetence here is infuriating. In addition, and just as crucial to the chain of failures, the Lewis Berger firm was found to have not conducted any evaluations for conditions other than the finalized, fully assembled version of the bridge. The Lewis Berger engineer told investigators that, "My model was for the structure as one structure. Doing construction sequence staging analysis was not part of our scope. And again, doing such an analysis requires much more time than what we agreed about," referring to FIG Bridge Group. In a post-collapse interview, the Lewis Berger engineer stated, "In the beginning, I suggested to do this kind of analysis to analyze the connections. I'm talking about the nodes, or the joints, to analyze the connections. However, the budget and time to do this actually was not agreed upon with the designer."
The university says it followed all processes and procedures. FIU's president on Thursday confirmed that there were tests conducted on the bridge.
I have not spoken directly with Mania Construction, but I'm satisfied that the testing that was occurring was consistent with best practice.
Miami-based family business Munia Construction Management partnered with Fig Bridge Engineering and a secondary engineering firm, Lewis Berger Group.
We followed all processes, competitive bidding, two-phase process, independent engineering company that is fully certified by the state, that was recommended to us by FDOT.
So tolerances had not been factored in for the atypical stress put on any of these pieces during the ABC process. On top of this, since Fig's designs were inadequate even aside from factoring in the ABC process, it should have been glaring to a firm like Lewis Berger to catch at least this under-engineered final design, as that's the purpose of such a peer review process. Since Fig's calculations were so erroneous and upcoming forces remained so underestimated, nodes 1, 2, and 11, 12 would be so pathetically under-engineered, containing non-structural voids, essentially empty, wasted space within the concrete, and such insufficient rebar that it was inevitable cracking would occur almost immediately once the concrete had set in the assembly yard. And this is exactly what happened at node 1112. As frustrating as it is, this cracking was closely monitored and well documented over a period of 2 to 3 weeks. February 24th, a loud, distinct sound of cracking is heard from node 1112 as tensioning is finished and the false work removal process begins. March 10th, the SPMTs begin to move the main span, and over the next few days, during movement, detensioning, and placement onto the bridge piers, the cracks evolve significantly from what appeared as concerning originally to beyond alarming. By March 13th, reaching a depth of 2 to 3 inches now, and spreading rapidly all around the 1112 joint region. This could and should have easily been identified by those in the industry as the 1112 joint beginning to dislocate entirely from the bridge deck. Denny Pate, the one whose stamp of approval appears on the drawings, the primary engineer of record, and Fig Group vice president, was instrumental in pushing the narrative to all parties that these cracks pose no issue.
Hey Tom, this is Denny Pate with Fig Bridge Engineers. Obviously some repairs or whatever will have to be done, but from a safety perspective, we don't see that there's any issue there.
Pate then headed to Miami, and on March 15th, the day of collapse just a few hours prior, after viewing the cracks in person at 8 a.m., would hold a meeting at 9 a.m. with FIU, FDOT, MCM, Bolton Perez, and the rest to assure them there was nothing to be concerned about, at which time no parties expressed any desire to halt the work or close the road underneath the 950-ton now crumbling span. The decision was made instead to send workers up on the canopy in an attempt to re-stress member 11 using the post-tensioning rods. This decision was of course futile and grasping at straws by those in charge, as the cracking from the very beginning, to an engineer who gives a damn, should have been a message, a warning, the bridge screaming that it was already doomed to give way. The collapse took place that same afternoon during the re-stressing procedure. Initial frustrations on the NTSB's part when piecing this puzzle together with the mindsets that caused the collapse, this narrative didn't even stop when it collapsed. Groupthink. In a group, the tendency for individuals to uncritically agree to any decisions due to conformity. Groupthink is based on a common desire not to upset the balance of a group of people. It appears that the same mindset was in play here, in every organization. Fig, Lewis Berger, MCM, BPA, FDOT, and finally, FIU. It also appears that every organization absolved themselves of responsibility by rationalizing that if the engineer of record says it's okay, it must be okay, and if anything bad happens, it's on him. MCM was eventually forced to restructure, and along with Bolton Perez, both were fined, albeit minimally. Fig Group was fined most heavily and ended up debarred, removed, and disallowed from future Federal Highway Administration projects, which, from what I can find, they're continuing to appeal in court. They were also recently removed from the Houston Ship Channel project, a project they spotlighted heavily on their website, and from what I can find, updates on their site stopped around this time, and the website's copyright mark even shows 2020 still. A settlement of $103 million was shared with the families of the 10 injured and 6 lost. From NTSB Vice Chairman Bruce Landsberg, despite the public's anger, distress, and disappointment, none of the responsible organizations had any intent for this tragic event to occur or to cause any injury or loss of life. Sadly, Good intentions do not suffice for competence and diligence. Once the cracking became evident, not one of the organizations involved was willing to take the essential and unpopular step to call a halt and close the road. The human failing that affects all of us is complacency. It is not a term the NTSB uses often, but in my opinion, it's present in nearly every accident and crash. It is my fervent hope that the organizations involved will take the NTSB recommendations seriously and quickly implement them. The lives lost and the families disrupted deserve at least that much.